Nonmetallic sheet cable, often referred to as NM cable, is commonly used in residential wiring. When running NM cables through wood framing, it's often necessary to pass them through bored holes. Electrical codes address the number of NM cables permitted in a single bored hole to prevent overheating and ensure safe operation. Although the provided code snippet indicates a limit of 3 NM cables in a bored hole, it is crucial to consult the specific electrical code adopted by the local jurisdiction. The National Electrical Code, or NEC, is widely used as a basis for electrical regulations, but local amendments may exist. The NEC provides guidelines on cable fill in Chapter 3, specifically Article 310, which covers conductors for general wiring. While Article 310 primarily focuses on conductor ampacity and allowable ampacities in various conditions, it also references other articles that pertain to cable installations. To determine the exact number of NM cables allowed in bored holes, you should refer to NEC Section 314.16, which applies to boxes and conduit bodies. This section gives you full calculations for conduit and conduit bodies. The NEC doesn't explicitly state a number of NM cables allowed in bored holes, but it does discuss how to maintain the integrity of the cable and prevent damage due to heat buildup. The principle is to ensure that the cables are not bundled in a way that prevents heat dissipation, which could lead to conductor insulation breakdown and potential fire hazards. When NM cables are bundled together for more than 24 inches, their ampacity must be derated according to NEC Table 310.15b3. This derating reduces the allowable current the cables can carry. Since bored holes inherently create a bundling effect, limiting the number of cables helps to manage heat. If more than 3 NM cables are run through a single bored hole, it may be necessary to derate the ampacity of the conductors, potentially requiring the use of larger gauge wires. This is because the heat generated by multiple current-carrying conductors in close proximity can exceed the insulation's temperature rating, leading to premature failure. Proper installation practices also dictate that NM cables should be supported and secured within 12 inches of boxes, cabinets, and fittings, and at intervals not exceeding 4.5 feet along the run, as specified in NEC Section 334.30. This support minimizes strain on the cables and prevents them from sagging or being damaged. When passing NM cables through metal studs or framing members, use grommets or bushings to protect the cables from abrasion. Sharp edges can damage the cable sheath, exposing the conductors and creating a shock hazard. Always inspect NM cables for damage before installation. Any cable with cuts, abrasions, or other signs of damage should be replaced. Damaged insulation can compromise the cable's ability to safely carry current. When installing NM cables in thermal insulation, be mindful of the cable's ampacity. The NEC requires ampacity adjustment when cables are installed in thermal insulation, as this reduces their ability to dissipate heat. This is covered in NEC Section 310.15 Atwo. Ensure that the cables are rated for the temperature conditions in which they are installed. NM cables are typically rated for 90 degrees Celsius, but their ampacity is usually determined by the 60 degrees Celsius or 75 degrees Celsius column in the ampacity tables, depending on the termination temperature rating of the connected devices. If running NM cables in a damp or wet location, use cables that are specifically listed for that purpose. Standard NM cable is not suitable for use in wet environments. Also, when running cables parallel to framing members, maintain a distance of at least 1.25 inches from the nearest edge, or protect the cable with a steel plate at least 1/16 inch thick, as required by NEC Section 300.4d. This protects the cables from being penetrated by nails or screws. When making connections in electrical boxes, use the correct size wire connectors for the gauge of wire being used. Loose or improper connections can lead to arcing and overheating. Ensure that all connections are tight and secure. Grounding is a critical aspect of electrical safety. All metal boxes and equipment must be properly grounded. Use a grounding conductor in each NM cable and connect it to the grounding terminal in the box. This provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. When adding new circuits to an existing electrical panel, be sure to calculate the load in the panel to ensure that it is not overloaded. An overloaded panel can lead to overheating and potential fire hazards. Consider using a load management system to prevent overloading. Always use a properly sized circuit breaker or fuse to protect each circuit. The circuit breaker should be rated to protect the smallest gauge wire in the circuit. Overcurrent protection devices prevent damage to the wiring and equipment in the event of a short circuit or overload. Label all circuit breakers in the electrical panel clearly, indicating the circuits they protect. This makes it easier to identify and troubleshoot problems in the future. When working with electricity, always turn off the power to the circuit at the circuit breaker before starting any work. Use a voltage tester to verify that the power is off before touching any wires or connections. This helps to prevent electrical shock. Consider consulting with a qualified electrician for any electrical work that you are not comfortable doing yourself. Electrical work can be dangerous, and it is important to ensure that it is done safely and correctly. A licensed electrician has the training and experience to perform electrical work in accordance with the electrical code. When replacing an electrical receptacle or switch, be sure to use a device that is rated for the voltage and amperage of the circuit. Using the wrong device can create a safety hazard. Inspect electrical cords and extension cords regularly for damage. Replace any cords that are frayed or damaged. Do not overload extension cords. Overloading can cause the cord to overheat and create a fire hazard. Never run extension cords under rugs or carpets, where they can be damaged and create a tripping hazard. Use surge protectors to protect electronic equipment from voltage spikes. Voltage spikes can damage sensitive electronic components. Surge protectors can help to prevent damage from lightning strikes and other power surges. Install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. GFCIs detect ground faults and quickly shut off the power to prevent electrical shock. Test GFCIs regularly to ensure that they are working properly. Use arc fault circuit interrupters, or RFCIs, to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. RFCIs detect arc faults and quickly shut off the power to prevent fires. Consider using tamper-resistant receptacles in homes with young children. Tamper-resistant receptacles have shutters that prevent children from inserting objects into the slots. Educate children about electrical safety. Teach them not to play with electrical outlets or cords. Make sure they understand the dangers of electricity. Install smoke detectors on every level of your home and test them regularly. Smoke detectors can save lives by alerting you to a fire in its early stages. Have a fire extinguisher readily available and know how to use it. A fire extinguisher can help to put out a small fire before it spreads. Develop a fire escape plan and practice it regularly. Make sure everyone in your home knows what to do in the event of a fire. Keep flammable materials away from heat sources. Flammable materials can easily ignite if they are exposed to heat. Store flammable liquids in approved containers. Approved containers are designed to prevent leaks and spills. Have your electrical system inspected regularly by a qualified electrician. An inspection can help to identify potential problems before they become serious. Take a class on electrical safety. A class can teach you about the dangers of electricity and how to work safely with it. Be aware of the electrical hazards in your home and take steps to prevent them. Electrical safety is important for protecting yourself and your family from electrical shock and fire. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment such as rubber gloves and safety glasses. Use insulated tools. Work in a well-lit area. Avoid working in wet or damp conditions. Never work alone. If you are not comfortable working with electricity, hire a qualified electrician. Electricity is a powerful force and should be treated with respect. By following these safety tips, you can help to prevent electrical accidents and protect yourself and your family from harm. Remember, when in doubt, always consult with a qualified electrician. They can provide expert advice and ensure that your electrical system is safe and code compliant. While the initial code snippet and the 3-cable limit may not be a universal rule, understanding the underlying principles of heat management and cable protection is essential for safe and compliant electrical installations. Always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date information.